If you look up at the night sky, under good conditions you'll see thousands of stars. And as we know, almost all of them are orbited by planets. Billions of planets in our galaxy alone. This naturally leads one to wonder if what we have is really so special and rare, given that there are so many worlds in our galaxy alone. But let's start with what we actually have. Our solar system is, roughly speaking, divided into two regions. On the inside are the four rocky planets: Mercury, Venus, Earth, and Mars. On the outside are the four gas giants: Jupiter, Saturn, Uranus, and Neptune. Between them lies the asteroid belt, a broad ring of rock and dust that separates the two zones. That might sound unspectacular at first, but if you look more closely, there's more to this arrangement than meets the eye. Take the Sun, for example. It's a so-called G-dwarf, a medium-sized, relatively quiet star. No extreme radiation bursts, no wild periods of activity that would make life on Earth impossible. It has been burning steadily for about 4.6 billion years, and it will continue to do so for roughly the same amount of time. This stability is not something to be taken for granted. Many stars are significantly more restless, cooler, or shorter-lived. Our Sun is, in a sense, a steady landlord. Then there's the question of how all of this came about. About 4.6 billion years ago, a giant cloud of gas and dust collapsed under its own gravity. The Sun formed at its center. A rotating disk formed around it. And from this disk, the planets gradually emerged. Heavier elements accumulated in the center, lighter gases further out. This is how the characteristic division that still defines our solar system came about. What resulted is a system that has remained remarkably stable for billions of years. No major collisions, no planets knocked off their orbits, at least not in recent history. So everything worked out in such a way that we are able to exist today. However, when you consider everything that could have gone wrong, it quickly becomes clear that our solar system didn't simply form and then function on its own. It survived, and that's a crucial difference. Let's start with Jupiter. The largest planet in our system is, in many ways, our silent protector. Its enormous mass creates a gravitational field that either deflects or captures asteroids and comets hurtling toward the inner planets from the outer reaches of the solar system. Without Jupiter, Earth would be hit by large objects far more frequently. And the interesting thing is, in many other planetary systems we've discovered so far, there is no Jupiter in this position. Either such a massive planet is completely absent, or it sits far too close to its star, meaning it would have traversed the entire inner system on its way there, disrupting everything that had formed there. Then there's the Moon. Our Moon is unusually large for a rocky planet of our size. It likely originated when a Mars-sized body collided with Earth in the early solar system, an event that nearly destroyed Earth, but ultimately left behind something crucial for life. The Moon stabilizes the tilt of Earth's axis. Without it, this axis would wobble wildly for millions of years, between almost upright and extremely tilted. This would lead to extreme climate changes, so extreme that complex life as we know it would have had virtually no chance of developing. Earth's own location is also significant. We are situated in the so-called habitable zone of our Sun, that narrow band where temperatures allow liquid water to exist on the surface. A little closer to the Sun and the water evaporates. A little farther away and everything freezes permanently. Venus is too close, Mars too far, and both demonstrate how quickly things can go wrong. But even within this zone, not everything is guaranteed. Earth has a stable orbit, a functioning atmosphere, and a liquid iron core that generates a magnetic field and protects us from the Sun's cosmic radiation. Plate tectonics ensures that carbon circulates between Earth's surface and interior, a natural thermostat that has kept the climate roughly stable for billions of years. All of this together is not a single lucky coincidence. It's a chain of interlocking coincidences, and that's precisely the point. It's not life itself that might be rare. Simple microbes could very well be common in the universe. But a planet that fulfills all these conditions simultaneously, a stable sun, a protective gas giant, a large moon, tectonic activity, a magnetic field, and the right distance, could be a true exception. The universe is vast, but vast doesn't automatically mean that everything that's possible is also common. Sometimes the probabilities are so small that even with billions of attempts, only a few succeed. Whether we are one of these rare targets, the best way to answer that is to look at what the universe has to offer. Since the 1990s, we have discovered thousands of exoplanets, and what we have learned is this. Nature builds planetary systems differently than our own, significantly differently in most cases. The most common type of planet we know is the so-called super-Earth, a rocky planet that is larger than Earth but smaller than Neptune. That doesn't sound too bad at first, but many of these planets are very close to their star, with orbital periods of just a few days instead of a year. That's a far cry from a habitable zone. Then there are the hot Jupiters, gas giants similar in size to our Jupiter, but also extremely close to their star. How did these massive planets get there? The prevailing explanation is that they originally formed further out and then migrated inward, through the entire inner system, sweeping away and destroying everything that had formed there. Rocky planets in the habitable zone wouldn't stand a chance. And what about the stars themselves? Our Sun is a G-dwarf, quiet, long-lived, and of medium size. But the most common stars in the universe are red dwarfs, smaller, cooler, and at first glance, perhaps more hospitable to life because they burn for extremely long periods, trillions of years. The problem is, they are restless. They regularly hurl enormous bursts of radiation into space, known as flares. Planets in their habitable zone would have to be so close to these stars that they would likely be tidally locked, one side always facing the Sun, the other always in darkness, like our Moon to Earth. Whether complex life could arise under such conditions is highly questionable. So what we see when we look at the universe is this. Planets exist everywhere, yes, but stable rocky planets at the right distance, orbiting a quiet, long-lived star, in a system without wandering gas giants, that's a significantly smaller category. Our solar system isn't impossible, but it's not the norm either. So, how rare is our solar system really? And could there be other planets like Earth? That's the real question, of course. And the honest answer is, we don't know for sure. But we do know enough to at least give a rough estimate. Let's start with the numbers. In our galaxy, the Milky Way, there are an estimated 200 to 400 billion stars. According to current research, virtually every one of these stars has at least one planet. This means planets are not a rarity. They are the norm. But then it gets more complicated. When you add up all the conditions we just discussed, the right distance from the star, a stable magnetic field, a large protective moon, a Jupiter in the right position, plate tectonics, a quiet sun, this enormous number shrinks very quickly. Some scientists estimate that perhaps only a fraction of a percent of all planetary systems are truly comparable to ours. With 400 billion stars, that would still be millions of systems. But compared to the entirety of the universe, that's vanishingly small. And then there's another perspective that shouldn't be overlooked. We've been searching for planets like Earth for decades, and we have indeed found some candidates. Planets in the habitable zone, similar in size to Earth, orbiting Sun-like stars. Kepler 452b was one such candidate. Proxima Centauri b is in the nearest star system to us, only 4 light-years away. It too is located in its star's habitable zone. But, and this is crucial, habitable zone does not mean habitable. It simply means that liquid water on the surface would theoretically be possible. Whether these planets have an atmosphere, a magnetic field, tectonic activity, in most cases, we simply don't know. We see these worlds as tiny points of light, if at all. What's really going on their surface remains speculation for now. So what we can say is this: Earth-like planets probably exist, perhaps even many of them. But a solar system and a planet that resembles Earth, not only in size and distance, but also in everything else. In its history, its geology, its defense mechanisms. That's a completely different question. Earth isn't just a rocky planet at the right distance. It's the result of 4.6 billion years in which countless things could have gone wrong and didn't. To replicate this whole package, that could actually be extremely rare. So perhaps we're not alone in the universe. Perhaps somewhere out there are simple life forms, microbes floating in some subterranean ocean beneath a thick layer of ice, without light, without oxygen, but still alive. But that's not really the point. The truly crucial question is different. How often does something complex emerge from this simple life? How often does evolution leap forward? From the single cell to multicellular organisms, from multicellular organisms to animals, from animals to beings capable of gazing at the sky and wondering if they are alone. On Earth, this leap has occurred. But it also took almost 4 billion years, and it was anything but a given. There have been mass extinctions, ice ages, impacts, volcanic eruptions, events that have repeatedly brought life on Earth to the brink of extinction. And yet, each time, it has recovered, adapted, and evolved. Whether this was chance or some kind of inherent logic of life, we don't know. But what we can say is this: a planet like Earth isn't simply a rocky planet at the right distance from the right sun. It's the result of a long, improbable history. A history in which countless things could have gone wrong and didn't. The right collision created the moon. The right gas giant protected us. The right internal heat kept the tectonic plates moving. The right atmosphere held on instead of escaping. None of these factors alone is decisive, but all of them together, over billions of years, in precisely this combination, that could actually be something that occurs very rarely in the universe. So what we can say is that our solar system, which made our lives and your lives possible in the first place, is not the norm in our universe. It's extremely rare. To date, we haven't found a solar system that comes as close to ours. We have potential Earth-like planets, but only in a few aspects. There are many more, as we've discovered today. When you keep that in mind, the Earth, shining into the universe with a blue light, seems even more special. Not just because everyone says so, but because you now understand it. I hope you enjoyed the video, and I hope to see you next time.